All right, so Thursday, November 12th. I'm actually doing this a couple days early. Figured we haven't learned this yet. I haven't taught it to you guys, so this would be like some good practice for me to kind of figure out how I want to teach it and see if maybe we can come up with a couple of tricks that'll help us solve these using maybe Desmos or just to kind of simplify. So anyway, so today I can find the missing side of a right triangle using the Pythagorean theorem. So it's going to be, I think when we're finding the hypotenuse, you guys aren't going to have any issues. But when it comes to finding our legs, our A or B, those are going to be the trickier problems. There's a lot of different ways you can do this. So I'll just show you a bunch of different ways. And then at the end of it, we'll come up with kind of like a formula or so for each leg. All right, or maybe I'll try and keep it simple. We'll see. We'll just see. All right, so this is just a visual diagram of how the Pythagorean theorem actually works, right? So we know that our theorem is a squared plus b squared equals c squared. Well, if these are my sides, and I want to call a 3, 4b, and 5c, because 5 is my largest, right? I would have 3 squared plus 4 squared equals 5 squared. 5 squared. All right, well, look, 3 squared is 9, 4 squared is 16, and 5 squared is 25. So it's very spatial, right? You can see that this is actually 3 squared, right? So we have 1, 2, 3, 1, 2, 3. So this becomes an area, right? And we'll definitely talk more about that when we go over area and volume. But it also works with side B. We have 1, 2, 3, 4, right? So it's saying we have 4 units. Well, if we square that, we'll have 4, 2, 3, 4. And 4 times 4 would be 16. So that's saying there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 unit squares is what we have on this side. And we square that number. And then you can see the same for 5, right? 5 across, 5 across. And 5 times 5 is 25. So if we were to add this area, 9 unit squares, to this area of 16 unit squares, we would get this area, which is 25 unit squares. So it kind of shows you in a visual sense of how this formula or how this theorem actually works. All right, and that's kind of a very loose definition. But let's get into what we're really talking about today, and that is finding a missing side. All right, so I said it last class, one of the biggest things, at least to get us started, is to be able to find the hypotenuse, right? So if we're looking for the hypotenuse, I mentioned very quickly that it's always going to be opposite of the right angle. What we can notice in this question, it does not say not drawn to scale. And it has this right angle symbol in it, which means that it's telling us this is a right triangle. But we have to figure out what the value of C is that makes that statement true. All right, so when I draw my line from my right angle symbol, that's going to be my hypotenuse. So this right here is my hypotenuse. And I'm just going to abbreviate it for the sake of writing. So that's going to mean that this can be my A and this can be my B. All right, this is going to be my A, this is going to be my B. And I'm looking for C. Well, we know that our formula is A squared plus B squared equals C squared. All right, so let's just start plugging values in. Let's plug in what we know. Well, we know A is 8, so that's going to be 8 squared. We know B is 15, so that's going to be 15 squared. But we don't know what C is, so we're just going to keep C as C squared. Remember, you cannot forget about these square symbols. If you do, it's just going to throw you all the way down. You're just starting off wrong. It's not going to end pretty. All right, so we know that 8 squared is 64. And 15 squared, I believe that's 225, but let me double check. And it is 225, 225. And again, I still don't know what C squared is, so I'm just going along with it. All right, so when I add 64 and 225, I get 289, and that still equals C squared. All right, so what do we think we do here? What's our next step? Well, what's the inverse or the opposite of squaring something? All right, what's the inverse of squaring something? Well, the inverse of squaring something is taking the square root of something. So we're going to combine a little bit of what we learned in solving equations and inequalities, and we're going to take the square root of c squared. But if we do it to one side of the equation, we have to do it to the other. All right, and what this is going to do is this is going to cancel out, this square root is going to cancel out that square. So all I'm going to be left with is c. And then you can just put this right into Desmos, and you will have the square root of 289 is 17. All right, so your answer would be c equals 17. So for this to be in fact a right triangle, the hypotenuse, this side right here, has to equal 17. And you could check your work if you wanted to. Like I said, we have a squared plus b squared equals c squared. Right? You could plug in your 8 again, a squared plus 15 squared for b, and then plug in the one that you found, 17 squared for c, and you could check your work. I'm starting to realize through my limited time as an educator that students checking their work is something I really believe gets picked up more along the lines of high school and definitely in college. But here we are in 8th grade. If you want to be ahead of the curve, check your work. So we have 64 plus 225, and you know that 17 squared is 289. You can put all of these in Desmos, and when you add them together, you get 289. Now this may seem like an arbitrary step, but let's say you accidentally, hit the wrong button on the calculator, wrote something wrong, didn't add these two numbers right here correctly, and you got a different number, right? Especially if you get like a decimal, sometimes that's a red flag. Not all the time. Like we'll have some with decimals, but you might think this is an arbitrary step, but if these two numbers match, you are 100% sure that your answer is correct. All right, so let's talk about this again. Let's see if there's a way we can make this work in Desmos with not a lot of work. So we know that this is our hypotenuse, is going to be what we're looking for is x. So c is x. Remember, I like our a to be our smaller number. B is going to be our middle number, just like this said, just like it is in the alphabet. So my formula is a squared plus b squared equals c squared. Well, I don't want to put in all these numbers yet. All right, like I just want to look at this for what it is. This is an abstract statement. Shout out to Mr. Hall for the abstract line in class earlier today. Right? So I want to kind of come up with an equation, right? That's just going to make my life a little bit easier. All right, so I'm going to go ahead and take the square root of both sides. All right, and we know what that's going to do is cancel out this square here. So what that leaves me with is an a squared plus b squared equals c. Well, I know my a is 20 and I know my b is 21. So let me plug those in. So now I'm going to have a square root of 20 squared plus 21 squared. And that's going to equal c. So if I do this longhand way, you'll end up with, I don't know what all these are off the top of my head. You'll end up with the square root of 400 plus 441 equals c. And that'll be the square root of 841 equals c. And I have no idea what that is off the top of my head. And if you take the square root of that, you will get 29 equals c. All right, so that's the longhand way. And all we really did was just do this step. Instead of what we did here, where this was our last step, we made it our first step. But we did that for a reason, because we just want to see if we can come up with something to make our life a little bit easier. So let's see if I get rid of all of this. All right, let me go to Desmos. And actually, you know what? Let me get rid of all of this. All right, so now here we are, Desmos. Let me type in this equation that we figured out. So we have the square root of a squared plus b squared. I'm going to hit right. You have to hit right once to kind of get it out of the way. I'm going to hit equals. I'm not even going to put the c in because I don't know what c is. So I don't have anything to put in for c. So now I'm going to put in a equals and b equals. And what did we say our answer was? What did we say we got? We got, I believe we had c equals, of course, c equals 29, right? All right. So when we know a is 20, and we know b is 21. And look, right where we thought, right at the top, it gives us c equals 29. Right, so we kind of came up with a little equation that'll make things easier. Notice we don't have to put in a value for c. We don't have to write right here. We do not have to write a c equals because we don't know what c is, okay? Let me show you another thing that I've been talking about this a and b and how it doesn't really matter which one's which. It will at a certain point, and I think it will today. But let me just go ahead and put in 21 for A, and I'll put 20 in for B. I get the same answer. I still get 29 for C, which is correct. And you know that you can check that, right? And that's because you're adding. When you're adding two numbers, it doesn't really matter what order they're in. It only really gets tricky when you're subtracting. So we kind of came up with a little formula. All right, so that seems nice, helpful. Right, so you're going to want to go ahead and remember, we put in A equals, B equals, and that's going to give us C. And this is to find C, or the hypotenuse. This only works when you're finding the hypotenuse. All right, we have a couple more questions, and I'll show you why. All right, what's the missing value of this right triangle? Again, we have our right angle symbol. And when I draw my line out, opposite it, you'll see that that's my hypotenuse. You can also tell that 19.5 is bigger than 7.5. Is it bigger than x? We don't know what x is, but I can guarantee you that it is because the hypotenuse is always opposite our right angle symbol. So that means this number has to be the biggest. All right. Since I believe we're just looking at triangles, instead we're not just looking at raw numbers, so I'm going to have C equals. We know that that's C. That's definitely C. Well, I don't know if X is bigger than 7.5 or if 7.5 is bigger than X, but I'm going to make 7.5 equal to A. And we're going to look for B. We're going to look for B. Let me make sure. Yep. All right. Now you could switch out. This could be A, this could be B. It's up to you. And I'll do another one where they're different. But, you know, that's really up to you. But this is where I like to pick one and stick with it, right? That's my thing. Pick one, stick with it. So I know that I have my formula, A squared plus B squared equals C squared. All right, so what is my A value? It is 7.5 squared plus B squared equals, and our C, we don't know what B is. And I'm not even going to bother putting an X in there for it right now. I'm just going to leave it as a B. Or maybe I'll go ahead and put it as an X just for whatever, just so you guys see it. All right. And then C is going to be 19.5 squared. These are ugly numbers, so I would suggest using Desmos to at least square them. So 7.5 squared will give you 56.25. We don't know what X is, so it just stays as X squared. And 19.5 times 19.5 gives you 380.25. So 19.5 squared gives you 380.25. Well, look, now we pretty much have a two-step equation. Just looks a little different because we have this unknown variable being squared. Well, first step is going to be to subtract 56.25. And that'll cancel out on the left. But if we do it to one side, we have to do it to the other. Right? And look, I'll have x squared equals, that's going to be 324, and the decimals go away. So it's just going to be 324. Well, just like before, all we have to do now is the opposite of what the squaring, the opposite of squaring a number, which is taking the square root. And what you'll see here, remember our square root cancels out our square, so we just have our x. And the square root of 324 is 18. So x equals 18. So this side, one of our legs was 18. All right, and again, you could check this. You could put in, I encourage you actually to check this. So let's say if we had a, it would be 7.5 squared plus 18 squared equals 19.5 squared. Right, so you can check this. All right, I'm telling you that it's right, so you don't have to check it, but I encourage you to check your own work. All right, let's try another one, but let's see if we can come up with an equation for this. All right, so I'm going to stick with A being the number we're looking for. I'm going to stick with A, or B being the value that we're looking for, sorry. So what I have here is 2, 2.5, and an M. Well, I know that this is a right triangle because it's my right angle symbol, which means that my hypotenuse is 2.5. All right, so that's my C. I'm going to keep this as my A. Remember, and we're going to look for B here. All right, so I'm going to write out my formula, my theorem. A squared plus B squared equals C squared. Well, I'm looking for B. This is what I'm looking for. I don't know what that is. So I want to get B by itself. So what I'm essentially doing is the same steps that I did here, but without putting any of the numbers in. I'm not doing any of the math yet. I'm just moving variables around using correct mathematical operations, but I'm moving them around more or less abstractly. So I'm going to subtract an A squared from both sides. So these will cancel out. And I will be left with a B squared equals C squared minus A squared. Well, I still want to get rid of this square. So I'm going to square root both sides. These cancel out. And I will be left with B equals the square root of C squared minus A squared. All right. Well, I don't know what B is, but I do know what A is, and I do know what C is. So let's pop this bad boy into Desmos and see if this is helpful. Get rid of, clear out your Desmos all the way on this one. And look, I'm going to use a square root. I'm going to say C squared because I know what C is, minus A squared. Press right equals, you don't even really have to hit equals, I'm just doing it because I can. A equals and C equals. So what did we say A was? We said A was 2. And we said C was 2.5. And right away it gives you what our B would be, which is 1.5. So B equals 1.5. Now again, I encourage you guys to check this, right? And actually, this is M equals because that's the variable we're looking for, but we called it B through the theorem. All right, so M equals 1.5. But I encourage you, go 2 squared plus 1.5 squared equals 2.5 squared. Test that out. If both sides equal each other, we're good to go. I'm telling you it is in fact correct. All right, 2 more. Let's try this one by hand. Oh, this guy's an easy one. These are our favorite kinds. We're looking for, we're looking for the hypotenuse. Oh, but look at the way the question's asked. Find the value of AC. What is that? AC with a line over it? Find the value of line segment AC. So it tells you that that's what we're looking for. Okay. But we know that that's going to be C equals, because that's going to be our hypotenuse because it's opposite our right angle. Well, 16 smaller, B is in the middle because we know C is going to be greatest. So we just set up A squared plus B squared equals C squared. Now we had a little formula that we could find for this. Right? It was C equals the square root of A squared plus B squared. Let's just pop that in Desmos, make our lives easier. I tried to make my life a lot easier and it didn't work. Plus B squared. This going to be B. So let's put in our A, which was 16. And we put in our B, which was 30. That is an ugly, ugly number. And I'd like to point out that I forgot to square my B. Right? A couple of things I want to point out here. I made a mistake. I didn't put my square root symbol in. So when I didn't do that, not only did we get a number that's not the largest out of the three for C, it's also really, really ugly. But when I square that B, you'll see that I get 34. And that's saying that C is equal to 34. Again, you can check it like I've showed you, plug all your A, B, and C in. Another way you can look at this is kind of a quick check, but is 34, since I found this is the value I found, is 34 greater than my B? Yes. Is it greater than my A? Yes. That's a peace of mind. But again, I encourage you to check your work all the way through. All right, last but not least, again, another line, looking for a line. Or we're looking for a line segment, I should say. So find the value of AT. Well, we know that our hypotenuse is going to be 10. So C equals 10. Remember, I like to look for B. So B equals. Well, for this one, we had a little formula that we found too. And that was that B equals the square root of C squared minus A squared. So let's pop that into Desmos and see if we can get something going. So we have C squared minus A squared. We're going to put a C in here. Well, I know that A equals 8 and C equals 10. And you'll see that it gives my value of B to equal 6. Again, you can check this. Couple of things I've said that I just want to be clear on. I usually pick A to be my smallest number, but when I'm doing a problem like this and I do not know what one of the legs are, I just pick A just to be consistent. And then obviously B is my smallest number, but like I've said before, A and B are interchangeable in these equations. Also, another quick check if you didn't want to do the long one. So I got B equals 6. Is 6 smaller than my hypotenuse? It is. So that's kind of a good peace of mind. All right, so we were able to come up with two formulas that might make it a little bit easier using Desmos for you guys. But that's, just a little intro to how to really think mathematically instead of just, just plugging and chugging and doing what you're told. I don't have a problem with Desmos, especially if you're trying to come up with an equation before, you start using the computer. But yeah, if you guys have any questions, let me know. Good luck, and I'll see you guys tomorrow.